Welcome to This Explainer. Today we're unpacking a concept that, well, it completely shatters our everyday perception of reality. We all pretty much live our lives by the clock, right? We watch the seconds tick by, and we just assume that time is this unyielding, invisible force marching forward at the exact same pace for everyone, everywhere in the universe. But what if time is actually flexible? Prepare to have your mind totally bent today, because we are looking at the extraordinary, almost unbelievable reality of time dilation.
To really wrap our heads around this, I want you to just imagine a scenario for a second. Picture this. You're exactly 25 years old. You board this highly advanced spacecraft, strap into your seat, and you blast off into the cosmos. Your ship accelerates and accelerates until it's traveling at an absolutely astonishing 99.99% of the speed of light. You cruise through the stars for what feels to you like exactly 5 years. You literally celebrate 5 normal birthdays on board.
But then you come home. You step off your ship expecting this huge, joyous reunion, and instead, you're hit with a deeply shocking paradox. While only 5 years pass from your astronaut perspective, from Earth's perspective, more than 50 years have passed. You are 30 years old, but everyone you knew has grown incredibly old. Your parents are gone, your friends have grandchildren. And honestly, the most mind-bending part of the whole shebang, your younger brother is now decades older than you are.
Section 1. The Illusion of Time. Einstein's Prediction.
Now you might be thinking, okay, this sounds like the plot of a fun science fiction movie, but it's actually a measurable reality. And it forces us to ask a deeply difficult question. What is time? Before we can even begin to understand time dilation, we really have to question our most basic everyday assumptions. Every single second, minute, and hour, we just naturally assume time flows identically for every single person. We think of it as this constant background hum to the universe. But Albert Einstein completely destroyed that idea. He showed us that time is not universal. It can stretch, it can slow down, and it can pass very differently for two different people.
So how did this massive shift in thinking happen? Well, for over 200 years, the scientific world completely believed Isaac Newton. He imagined time as this invisible, universal clock ticking equally across the entire universe, whether you were on Earth, Mars, or in some distant galaxy. But then, in 1905, a young patent clerk named Albert Einstein steps up and just completely changes physics forever. He replaced that rigid 200-year-old clock with the concept of flexible space-time.
Einstein based his revolutionary idea on one single, unchanging constant. He proposed that the speed of light is always exactly the same. No matter how fast you're moving towards it or away from it, light always travels at about 299,792 kilometers per second. That is the ultimate speed limit of the universe. And that single unbreakable fact? It completely breaks our traditional understanding of time. Because if light's speed never ever changes, then space and time must change instead.
Okay, let's dive into this. Section 2. How speed stretches time. The train experiment.
So how does moving faster actually alter the fundamental flow of seconds and minutes? It's kind of like a giant puzzle. To understand the mechanics of this, physicists use a classic thought experiment involving a moving train. Imagine a train moving really close to the speed of light. Inside, a passenger shines a flashlight straight up at a mirror on the ceiling, and the light bounces straight back down. Simple enough, right? But from the perspective of an observer standing outside the train, they see something completely different. Because the train is moving forward while the light is traveling up and down, that outside observer sees the light follow a much longer, diagonal path. So, here's the absolutely crucial point. The outside observer sees the light travel a physically longer distance, yet, as we just established, the speed of light remains exactly the same for both people. It doesn't magically speed up to cover that extra diagonal distance. If the light travels farther but keeps the exact same speed, well, something else must give. And this brilliantly illustrates the core of relativity. To make the math actually work, time itself must slow down. For the moving passenger, their clock is running literally slower relative to the person standing outside.
The actual math scientists use to calculate this is the time dilation formula. You've got t as the observed time, v is the object's speed, and c is the speed of light. Just look at that denominator for a second. As your velocity, your speed, gets closer and closer to the speed of light, that bottom half of the equation gets incredibly small. That means the observed time, t, becomes much, much larger. It stretches. And at the speed of light itself, the equation breaks down completely, which, by the way, perfectly explains why only massless particles, like photons, can ever travel that fast.
Let's anchor all that math with the famous twin paradox.
If astronauts travel at 99.9% of the speed of light, their journey might last exactly 10 years with totally normal biological aging. Their heart speed normally, their aging field's completely standard. But meanwhile, over 200 years have passed back on Earth. Entire generations have lived and died. This isn't magic, and it's not an illusion. Time itself actually stretched for those astronauts.
Section 3. Gravity bends the clock. Gravitational dilation.
All right, let's shift our focus to the next concept and see how this builds. Because get this, speed isn't the only thing that manipulates the clock. We need to talk about the heavyweights of the cosmos, because gravity also changes time. Out in deep space, where gravity is incredibly weak, time flows normally. But near a supermassive object, like a neutron star or a black hole, time almost grinds to a halt. Mass actually bends the fabric of space and time. Imagine standing near the event horizon of a black hole. 1 hour for you could equal years, decades, or even centuries for someone observing you from far away. If you've seen the movie Interstellar, you know where 1 hour on that water planet equaled 7 years on Earth? That wasn't just Hollywood magic. That was based on very real gravitational time dilation.
Section 4. Proof in your pocket. Measurable reality.
Now, you might be sitting there thinking, okay, this only matters for astronauts and black holes, but let's bring this abstract physics right back down to Earth, because this isn't just theory anymore. Scientists have actually placed incredibly precise atomic clocks on fast-flying airplanes, and when they land, they literally tick differently than the exact same clocks left on the ground. Also, these tiny particles called muons, they survive much longer than they naturally should when moving near light speed, simply because their internal clocks slow down. But honestly, the most practical proof is sitting right in your pocket, your smartphone. GPS satellites orbit Earth at high speeds and in weaker gravity. Without constantly correcting for both speed and gravitational time dilation, your phone's GPS navigation would drift by several kilometers every single day. You'd literally get lost without Einstein's math.
Section 5. Traveling to the future, nature allows it.
And this naturally brings us to perhaps the most exciting realization of the whole explainer. Because time stretches and bends, time travel to the future isn't just a fantasy. It is absolutely real, and it is actively permitted by the laws of nature. Traveling near light speed equals experiencing less time than those who remain stationary. So, while the laws of physics heavily restrict traveling backward into the past, arriving in Earth's future is a genuine reality. We're simply waiting on the engineering. If we can build a spacecraft fast enough to push close to that absolute speed limit, whoever boards that ship will essentially become a real-life time traveler, stepping off into a future Earth.
So, let's summarize what we've actually learned from Einstein's absolute genius here. Time is not fixed. It's not this invisible, rigid cosmic clock just ticking away in the background. It bends, it stretches, and it slows down depending on exactly how fast you're moving and how much gravity is pulling on you. Time is an emergent, flexible property, deeply woven into the very fabric of space-time itself. The universe actively manipulates it.
Which honestly leaves us with one of science's greatest, most profound mysteries. Does time even exist in the way we think it does? Some physicists actually believe the past, present, and future all exist simultaneously. Perhaps time isn't what flows. Maybe we do. I mean, think about it. Every second of your life, you are already moving through space-time. The only question is, how fast? If this explainer changed the way you think about time, make sure to hit that like button, subscribe, and turn on notifications. So what topic should we tackle next? Wormholes, quantum time, or maybe the theory of everything? Let us know down in the comments below.